And we are back. नहीं. And we are आंखें बंद हो रही है ना बहुत ज़्यादा. And we are back. Oh, we are back. And we are back with the eagerly awaited second part in a video series on making and calibrating a drone. Boy, that was a mouthful. Now I know you guys have been waiting a while, but as our elders love to say, sabr ka phal meetha hota hai. Enough talk about sabr and phal. Let's come back to drone. We all love flying drones, right? So for your benefit, we have divided this video into 3 sections. In first section, we talk about the propeller balancing and arrangement. In the second section, we talk about transmitter and receiver binding. And in the third section, we talk about the KK board calibration. So let's start with propeller balancing and arrangements. As you go deep into the making of a drone, you start coming across this term propeller balancing more frequently. I'm sure you're wondering what it is and why is it done. It is done to minimize the noise and vibrations. So the logic behind balancing is that weight of both the blades of propeller is not exactly the same. There is a minute difference in the weight of these blades, due to which vibrations occur and makes the drone unstable. So what we have here is a propeller balancer. If you have the Avishkaar kit, it will be easier for you to make and balance all the flow propellers without any difficulties, as we are going to do it right here. So basically what we have to do is put some sellotape on one of the blades which has lesser weight, just like this. Just make sure there are no air bubbles while applying the tape. In the same way, check and balance the remaining 3 propellers also. Now we'll talk about propeller arrangement, how it is to be done and why it is to be done. So propellers are arranged in such a manner so as to counter the torque produced by all the 4 arms by placing 2 clockwise propellers and 2 counterclockwise propellers. So the propeller which has R written on it is used for clockwise rotation and the other one is used for counterclockwise rotation. So motor 1 and motor 3 are mounted with clockwise propellers, whereas motor 2 and motor 4 are mounted with counterclockwise propellers. This arrangement is very important for the drone to avoid any unnecessary rotation. But as a precautionary measure, we are not going to mount the propellers just yet. We will do so after the KK board calibration is done. Now let's move on to the next part, which is transmitter and receiver binding. This step is to make sure that you are connected to the right receiver. To bind your transmitter and receiver, you have to follow the following 3 steps. The pins labeled as BAT on your RF receiver are your bind pins. The first step is to short the signal and ground pins of BAT to put the receiver in binding mode. The second step is to connect the LiPo battery to the drone. Now for the third and final step, press and hold the bind range test button on your RF transmitter and turn the power on. Make sure to remove the binding cable from the receiver module before switching on the power again. Now you can see the red light will continuously glow in the receiver, which means that you are successfully bounded with the transmitter. Now let's move on to the last part of this video, which is KK board calibration. Calibration is done in total 10 steps. The first step is to factory reset the KK board. As you scroll down the main menu, you will find this option. Press enter to reset. It will take around 5 seconds for the drone to reset. Then press back and an option will appear for mode selection on the screen. Scroll down to quadcopter X mode because our design is in an X shape and press enter. Then press back twice to return to main menu and proceed to the next step, which is accelerometer calibration. Now scroll down in the main menu and search for accelerometer calibration and place your drone on a flat surface. Then press enter. It will take around 4 to 5 seconds for this step to complete. The next step is to change the miscellaneous settings. Now scroll up and search for miscellaneous setting 1 and press enter. Scroll down to alarm 1/10 volts and change its value to 105. Select PI editor option and make sure axis is set to aileron and change P gain value to 45, P limit to 100, I gain to 25 and I limit to 20. After that, change axis to rudder and set the P gain value to 60, P limit to 20, I gain to 30 and I limit to 10. Now select self-leveling setting and press enter and change the value of P gain and P limit to 60. Now it is time to test our receiver. Before starting, make sure that all the sticks on the transmitter are set to their initial positions and then turn on the transmitter. After that, select receiver test in main menu and you will see some values appearing. Set all the values to 0 with trim buttons on the transmitter. Now go to mode settings in main menu and make sure self level is set to aux. We will now start with ESC calibration. We calibrate our ESCs to make sure that all of our motors start at the same time when we increase the throttle. To do this, remove the battery from the drone and turn on the transmitter and push the throttle stick up. Now press the first and fourth button of KK board simultaneously and connect the battery. Now the message throttle pass-through will appear on the screen. Now push the throttle stick down slowly and you will be able to hear the beep sound of calibration. Beep sound means we are done with the ESC calibration. Now let's move on to the last step, which is arming the drone. This is done by moving the left stick to the bottom right and the screen in KK board will show the status whether it is armed or not. You can even see the red light continuously glowing on KK board after arming. This is the indication that the drone is now ready to fly. Just push the throttle stick up and then the motors will start to rotate. Now before mounting the propellers, make sure that all the motors are rotating in right directions. Motor 1 and motor 3 should rotate in clockwise direction, whereas motor 2 and motor 4 should rotate in counterclockwise direction. If not, then simply swap out any two wires of the motor which is not rotating properly and you should be good to go. Now all we have to do is mount the propellers and our drone is ready to fly. I hope you guys found this video informational, so go ahead, build your own drone and experience the joy of flying. In the meantime, drop us comments below and don't forget to like and share the video. Keep making.